I'd like to introduce the first speaker. This seriously looking gentleman is Adam Badura. Now, one thing that you want to know about Adam, that he is the main organizer of Code Dive this year, so he's the brains behind all the conference. I think this is a reason for applause number one.
It was a team effort.
But also, if anything goes wrong, you want to blame Adam as well. So, you know, it comes with a cost. Now, the second thing is that Adam is a software developer and architect at Nokia. He has over 10 years of experience. However, his interest in programming, mainly C++, is a lot older. Adam's interests are mostly development of good software across all levels, from general design to technical details of specific implementation. And also Adam is possibly the newest dad at Code Dive. This is the 5th Code Dive, right? And his 5th child was born 5 weeks ago. How perfect can that be? Adam Badura.
Okay, welcome. Today I'm going to show you a small library about getting type name at compile time. Let's first start with the basic getting the function name, because that's pretty well known. We have the func symbol, which was standardized some time ago already. And there are some older symbols provided by vendor-specific extension. It's the pretty function, and for GCC and Clang. Interestingly, they are not the same. They differ slightly in both of those compilers. And then is this func-seq from Visual Studio. Perhaps the easiest way is to use Boost version, the current function. If you look into the implementation, you will notice that it's essentially tries to do pretty function or func-seq. Then it falls back to func if standard supports it. There is some workaround for old Borland compiler. I'm not even sure if it's still in use. However, that's about the function name. Now, when it goes to the class name, you will quickly find that many people already looked for a similar solution for the class name, and surprisingly, there is none. Surprisingly, because I think it's a syntax issue. The compiler knows what's the class name or what's the type name as a string, and I think the compiler could easily provide the name, but there is no syntax for it, so it's difficult to get it, not conceptually, but syntactically. However, not anymore. The library I developed, type name, offers the way to query the type name in the compile time. As you can see, there is this new syntax of the using variable with the extension v, so you can use it as if it was a variable, and it behaves like a meta function. You can use it at compile time, as you can see in the static assert. The library requires C++ 17. However, as I will explain later, maybe it could be tweaked to support older versions as well. Now, this is achieved with the help of the first mentioned macros. Those are not really macros, but they act and are named as if they were macros. You can use them or abuse to get the type name. If you would print those macros, those names using a simple function, you will notice that all the names, the generated names, fall into this pattern, with the GCC and Clang being almost the same, with the difference of the width word. I don't know why they decided to differ on that, but I think it's stupid, but okay. And then there is the Visual Studio, which differs more from that pattern, but they have all in common that the type provided as a template argument shows up in the name. And since those are essentially, there is a note about func. func is useless for it because it's consistent on all compilers and contains the name alone. It's not, per my understanding, it's not a requirement from the standard to be exactly and precisely only the name, but the compilers choose so it's the type doesn't show here anywhere, so you cannot use it. Now, the underlying type of those, the pretty function or funcseek, it looks like a macro, but it's not a macro. If you would force the compiler to only preprocess the file, you will see that those symbols are still there. They are not replaced by the strings because those are not macros. And at the point of preprocessing, they cannot be determined. Only the compiler, once it starts compiling the code, knows what's the function name. The preprocessor doesn't see functions. There are no functions from the preprocessor point of view. And so they only look and slightly behave like macros. They are not macros. But in the end, they act as if they were string literals put directly in this place. As the func symbol, the standard one even is precisely defined to be like that. And so you use them much like you would use the file macro. So if they behave like string literals, you can use them in string view. And that's why the library requires C++ 17 because of the use of the string view. You can capture you can first capture the function name. Obviously, you would use a different name for the Visual Studio compiler. Then we create some markers so that we can find within the original string, we can find the part that is of interest for us. Obviously, those would be somewhat different for the Visual C++, and with Clang you would get out with this width part. But the idea is the same. You have a left and a right marker. Then there is this block which does nothing more than just look up in the full name the part which consists of the type template type name. And once we once we get those the indexes properly, we can just query the substring from the string view to return the original the type name. So that's pretty simple. There is, however, some problem with it. First trick is that you return a string view rather than string, which makes it far less comfortable in printing. It's pretty simple with streams, C++ streams, because you can just print a string view, but it's not so easy with the C-style, printf style printing, which happens to be the choice in some cases. Like, for example, in our environment, all the logging is done using functions in this style, and the string view is not so useful there. Note that you could not use the string view directly as just the data pointer, because the string continues on, and either you would go into, there is no null terminator, so either you would print parts of the original function name which don't really belong to the type name, or you would get into memory that you shouldn't even touch. So you have to explicitly state what's the size of the string that you are going to print, which makes the syntax rather ugly. The unpleasant part is also that this method is not aware of aliases. If you use like size t, it will return, it will name the type and the underlying type. Sometimes it's useful, other times it's not, because typically when you are looking for overloads or something like that, you would prefer to use the alias because that's what you have in the code, so it would be much easier to find. Well, that's another syntax issue. For the compiler, it would be easy to provide both names because it knows both names, but well, we don't have syntax for it, sadly. And obviously, it's compiler dependent. With the simple types like the built-in int, bool, or like, they are all consistent and they show as you expect. They don't have to because it's based on compiler vendor-specific extension, but they are consistent about it. But when it comes to complex types, well, they differ. You here can see that Again, GCC and Clang differ even in the simplest thing like what's the name of the string. No need to mention that Visual C++, of course, uses different names as well. And the more complex the type is, the more the differences and various syntax flavors for how the particular compiler likes to name types. The library is placed on GitHub. You can see there how it's implemented. The implementation doesn't really cross over what I showed you in the function. That's the core of the implementation. There is some variety to support different types of compilers. So to not require the fullest standard, I have done some workarounds to support GCC up to version 7.3 and Clang from version 5. It's difficult to support Visual Studio because it keeps having some problems with const expressions, and I didn't manage to make a version that would consistently work. Each time they release new version, they will solve some problems, but another problem shows up, and I hope they will make it, but they didn't. But the idea is the same. So once they are done with their corrections, this would work with Visual Studio as well. There is one interesting thing that I wanted to show you with this. Oh, let's hope it will work. There is one interesting thing. Okay, it will not work. Sorry. I will just have to describe you. If you would use this library in the compiler explorer, you would notice that you always get the full string. Even though the simple program ends up using just like the int part of the name of the full macro, the binary always embeds the full string. I don't know why it's that. I try to change, for example, and optimize against size in hoping that compiler will get rid of the parts of the constant string that are not ever used by the code, but it doesn't. It always embeds the full name. I don't think it's a practical problem. However, there's a curiosity. I don't know why it happens that compiler doesn't get rid of those parts of the string. So that's it. If you have any questions,
please ask, but just one, because we need to quickly switch to the next speaker. Any questions? 3, 2, 1, and...
Okay. So thank you. Just in case I can...
Thank you very much, Mr. Badura.